This wall was completely empty. With some careful measuring, a few IKEA pieces, a plan in Fusion, and a bit of 3D printing, we turned it into a custom bookshelf wall. Let me show you how. Jump to minute 7 if you're only interested in the products used in this project. But stick around if you want to learn a simple process for 3D modeling and sketching. Keyboard shortcuts are shown in the bottom left corner throughout this tutorial. I'm using Autodesk Fusion, the tool I trust for all my design projects. And if you're into 3D modeling, it's a great one to learn. In Fusion, I work in full scale, 1:1, and start by creating a new component to keep everything organized. But you don't need Fusion to follow along. You can sketch this on a A4-sized paper using a 1:25 scale, where 1 centimeter equals 25 centimeters in real life. At that scale, the room, 6.2 meters wide and 2.4 meters high, fits almost perfectly on a single A4-sized sheet in landscape orientation. Or go hands-on later and cut cardboard pieces to test your bookshelf layout. Now I'm adding dimensions to the sketch. This step is important because it locks down the size of the room. We're not just drawing shapes, we're defining real-world measurements. The black lines you see here mean the sketch is fully defined. That means everything has a fixed position and size, and nothing can accidentally move or stretch. It's a simple habit, but it can save a lot of frustration later when we work with more details. Once you've sketched the room and the door opening, extrude the room slightly to give it some visual depth. If your sketch turns invisible, just toggle its visibility back on so you can use it. And if you're following along with cardboard pieces or an A4 sketch, the 2100 mm high door becomes 84 mm at a 1:25 scale. Just divide any real measurement by 25 to get the scaled size. You can go ahead and add an appearance to your model now, but don't worry about picking the perfect one just yet. It's easy to come back and adjust appearances later. Fusion's powerful rendering tools let you test different colors digitally before spending money on real paint at your local hardware store. Click the arrow icon to download your selected appearance, then simply drag and drop it onto your model to apply it. Next, switch from the wall component to the main component. From here, create a new component and name it Billy. This ensures that the Billy component sits at the same hierarchical level as the wall, keeping your model organized and easy to manage. Feel free to add key dimensions directly in the model name to make it crystal clear what this component represents. We're using a top-down design approach, which means we sketch directly onto our wall. This allows us to build everything in place. It's different from a bottom-up approach, where components are modeled separately and later assembled. Start by creating a rough sketch. Any size will do for now. Then add dimensions to set the exact size: 400 mm wide, 2020 mm high, and 280 mm deep. If you're following along with pen and paper at a 1:25 scale, that translates to 16 mm wide and 80 mm high. The depth, 280 mm, can be tricky to show in a 2D sketch, so don't worry too much about that for now. From here, it's easy to turn this solid body into a bookshelf using the shell command. A wall thickness of 20 mm works well for this project, even if it's not an exact match to the real Billy bookshelf. The goal isn't perfect accuracy. It's to build a digital model that helps us plan before making any real-life purchases. Next, we'll create the shelves. There are several ways to do this, but in this tutorial I'll go with a simple method. We make one shelf and copy it. This makes it easy to adjust later if you're building it yourself. If you plan to outsource the assembly, you can take it a step further by adding dimensions and generating a drawing. That way, whoever builds it will know exactly what to do. The 670mm height from the bottom is adjusted to fit the hatch, which we'll return to later. When creating the shelf, make sure to set the operation type to new body. This allows you to easily make individual copies. One great thing about this design is how 3D print friendly it is. Whether you use PLA or PETG, it's easy to prototype or customize. If your partner is into home design but not yet convinced about 3D printing, this might even be your perfect excuse to get a printer. I'll fast forward through the rest of the shelf height adjustments. You get the idea by now. Just make sure to tick the Create Copy box and everything will go smoothly. One advantage of this workflow is how quick and easy it is to set up. A sketch-based approach would offer more flexibility for future adjustments, but every workflow has its trade-offs. Since I knew I wouldn't need to tweak this much, real-life looks would guide the final result. I chose the faster route. Next, we'll add the top shelf. This will be the final design step in this tutorial. By now, we've covered the basics of how to model this kind of setup in Fusion. From here, we can shift focus to the different IKEA products used in the Billy Bookshelf wall project, along with some practical tips and tricks for real-world execution. Build the top shelf in place. Start your sketch directly on top of the Billy Bookshelf. Use the project command to bring in reference edges and create linked sketch lines. Then extrude the profile upwards by 350mm. That's the height for this section. To finish, use the shell command to hollow it out using the same wall thickness as before, 20mm. The top shelf is done, and it looks great. Now that you've seen how straightforward modeling can be in Fusion, let's jump ahead and take a look at the IKEA products used in this bookshelf wall project. At the far right end, it's not actually an IKEA product. To fill the gap between the last Billy bookshelf and the wall, we used a wooden plank from a local hardware store. It has the same finish as the Billy units, so it blends in seamlessly and gives the whole bookshelf wall a built-in look. Next up is the white IKEA Billy bookshelf, 40 cm wide, 28 cm deep, and 202 cm high. On top of it, we've added the matching Billy over shelf, which measures 40 by 28 by 35 centimeters. Both are standard IKEA products, and I'll link to them in the video description if you want to check them out. The next part is a small wooden trim piece, bought from a local hardware store. It has the same finish as the rest of the bookshelf wall, so it blends in almost completely. It's hard to spot in the images. One of the benefits of modeling everything in Fusion ahead of time was that we could identify these small dead spaces early and use them to create a cleaner, more built-in look. 4 wide Billy bookcases, each measuring 80 by 28 by 202 centimeters, were used in the project. We cut 2 of them down to 67 centimeters from the floor and placed a countertop with the same white finish as the Billy bookcases on top. For the 2 wide Billy bookcases that we kept at their original height, we added the matching IKEA height extension units. All units were securely anchored following the store's safety recommendations. On the outer edge, we attached a board with the same finish as the other IKEA products. Like all the other custom elements used between the different versions of the Billy bookcase, it was securely fastened using several metal brackets. Be careful not to use screws that are too long when attaching anything to the Billy bookcases, as you might accidentally drive them all the way through. Since there was an adjoining ventilation vent, we made sure to cut out space for airflow and installed a sleek cover grill for a clean finish. To finish the project, we used IKEA's Sunnydal kitchen fronts, 40 by 60 centimeters, as doors. Since they are kitchen doors, mounting them was trickier than usual. We had to drill our own holes, but the clean, finished look was worth it. We also filled and painted the unused shelf pin holes on the Billy units for a smooth, seamless finish. It looks great, but you lose some flexibility if you want to move the shelves later. This project was a bit different from my usual 3D printing builds, but it's a good reminder that Fusion is great for planning all kinds of projects. I'd love to see more people share their own builds on YouTube. If you're thinking about making videos, I recommend Camtasia. It's packed with useful features and there's an affiliate link in the description. Thanks for watching and I'll see you soon in the next project.